Hello everyone, my name is Alex Perfilev and this is a short video of my cloth simulation. Here we start with the menu where you can set up initial parameters of the cloth, such as width of the cloth, height of the cloth, its mass, and coefficients of the springs that forms the cloth. There are three different types of springs: structural springs, shear springs, and bend springs. I'm going to explain about them in a little bit, but for right now let me just set them to some arbitrary values and create the cloth. The top two corners of the created cloth are not being updated. This is done just so it won't fall off the screen. As you might notice, the menu is changed and there are now more options available. We still can change the mass of the cloth. The bigger the mass of the cloth, the more it will sag under its own weight. And vice versa, the less mass it has, the less it will sag. The whole cloth is composed of point masses and springs that connect them. The mass is distributed evenly between all the points. We still can modify the spring coefficient of all three spring types. And now we can choose to draw them or not, as well as the mesh of the cloth. So let me turn off the drawing of the mesh, so you guys can see better what each spring type actually is. The structural springs connect point masses vertically and horizontally, allowing me to control how much cloth stretches horizontally and vertically. Likewise, the shear springs connect point masses diagonally, which allows me to control how much the cloth stretches diagonally. Finally, the bend springs connect every other point of mass horizontally and vertically, allowing me to control how the cloth bends. Basically, the stiffer all three types of these springs are, the more rigid the cloth will look. Here, let me allow to draw the mesh again, so you guys can see better how it behaves when I modify each spring. And this slider is just a different cloths with different values that I played around with earlier. I also implemented a simple wind mechanics for this cloth simulation. The bottom three sliders are the direction of the wind in 3D space. So right now the wind will blow towards us and down. This fourth slider is the strength of the wind. It is 0 now, so this is why we don't see any wind yet. Let me increase it. Here we go. The periodic wind toggle is just making wind look a little bit more interesting by using the sine function that depends on the time and modifies the wind direction ever so slightly in all three directions. This makes wind to look a little bit more chaotic. When I'm applying the wind to each point of mass in the cloth, I look at the vertex normal of the mesh and use dot product operation with the wind direction to figure out how much of the wind should be really applied to that point in the cloth. So if the wind blows perpendicular onto the cloth should move a lot more. And if the wind blows along the cloth or parallel to it, it will have a lot less motion. This toggle option allows me to see each vertex normal in the cloth. Right above it is a toggle that allows me to see velocity of each point of the mass in the cloth. Finally, I'm using two different integrators to solve the equation of motion for each point of mass in the cloth. They are the semi-implicit Euler method and the Runge-Kutta fourth order method. The left option of this switch is the semi-implicit Euler method, and the right one is the Runge-Kutta fourth order method. The semi-implicit Euler method makes a lot less calculations, and as a result it is faster, but also converges the solution a lot slower than Runge-Kutta fourth order method. So for example, under the wind, the cloth would naturally try to be parallel to the direction of the wind, because that would make the cloth to do least amount of action. It will try to find an equilibrium position such that it does not move anymore, even under the wind. But there are a lot of points in this cloth and they all depend on each other, which makes it very hard to find the equilibrium position. So here we can see that the semi-implicit Euler method is further away from the actual solution, which is the equilibrium position, while Runge-Kutta fourth order method makes cloth looks a lot more relaxed and closer to finding the equilibrium position. In the end, of course, it is up to the user to pick whichever one fits better for the job. In this simulation, I'm obtaining all equations of motions for each point of mass in the cloth by using Euler-Lagrange equation in which I just plug in all the energies that are affecting this system. Once I obtain the equation of motion of each point of mass in the cloth, I plug them into the specified by user integrator to update its position and velocity. Alright, I think I covered everything I have so far in this simulation. In the future, I'm planning to add collision detection and resolution, so it doesn't sink through itself and can collide with other objects. As of right now, this is it. Thank you for watching this video.